Hello everyone. In this video, I want to show you a very simple static analysis of forces on a dam in SolidWorks. And the elements that I want to show you that are new to my playlist are advanced, basically fixture or reference geometry, and a roller, as well as forces that are varying with location. They are non-uniform forces, which is the hydrostatic force behind the dam. Okay, this force here that starts at the top of the basically water from zero and then goes down, and the force is rho gh, where rho is the density of the water and g is the g of gravity and h is the height, the depth in water. The force that is due to water going underneath the dam, call it the uplift force, which you can see here, which starts maximum at this bottom corner of rho g, the total height. Then as you go toward the other end and there is not barely any water, that force gradually goes to zero. And of course the gravity. So this is that. And one extra thing that I did when I started modeling this simple thing, I was looking at the material, and of course, you know, when you go to the regular material of SolidWorks, there is no concrete. So I was looking into a way to add concrete material to SolidWorks, and I found that if you go to GrabCAD here, this person, I don't know if I can pronounce it correctly or not, Lala, I assume, if that is L, he or she added this amazing file. So you can download this RAR file and then extract it. And once you download it, let me show you. So here, if you go to, guess it's data as no, should be this one. Yes. So you need to copy this concrete SLD mat. It's a SolidWorks material concrete. You go and it's a library. It's a custom library. You copy this. And then you go to your program data, right? And then go to SolidWorks. And then copy it into, let me show you, custom material here. So that is going to add this custom library. So now if you go to SolidWorks, when you right click and you want to edit material, you should be able to go under custom material, and there is this library now called concrete, and there are several categories. There is even asphalt. Okay, and there's concrete by weight and concrete by strength. Here I used Portland high strength concrete. So this is another interesting thing that I wanted to add to this video. So now what are my constraints here? So on these faces, I added a what we call an advanced fixture. So you go to advanced fixture. And then for advanced fixture, you need to pick a surface. Let's say here, for instance, this surface. And then you can pick a reference. Let's just pick the same thing for reference. And then there are 3 directions for displacement, and you can constrain any of them to 0 or a fixed number if you want. So if I do this, now if you can see in this direction, in this X direction, all of the displacements will be set to 0. And then I can, for instance, add this direction, which is Z. And now in the Z direction, everything is 0. But let's say in the Y direction, everything is free to go. Okay, so you can basically eliminate any of the degrees of freedom that you want with this custom fixture, because if you add the fixed geometry, it automatically takes all 3 away. If you do roller, then it will only do normal, the translation normal to the surface. That is going to be 0. But with this advanced one, you can do any combination that you want. So that's what I did to these 2 left and right surfaces. And as you can see, the normal force, because typically a dam is made between, like, say, 2 big sets of rocks, right, in some valley where the river is going. So there is some normal force from those, and then because of friction, there is some lateral force here in the X direction, which doesn't let this guy move left and right. And then on the bottom, I added a roller. So there is some force from the foundation underneath, okay? And that is a simple Y force, as you can see here, these green guys. So it cannot go up and down. And then for gravity, you just go ahead and just add the gravity. You just need a reference plane. I pick the top plane and make sure the direction of this is correct. And here you provide the G of gravity. You can do more advanced settings if you want, but here it is good enough for me. Then here, let me show you how I did the hydrostatic force. So for hydrostatic force, I applied it to this portion of the surface. And that is another thing I want to talk about. That's called a split line. So I applied it only to this portion of the surface, not all of it, which is about 30 meters. The whole height is about 40 meters. And so here you need a reference coordinate frame. So ahead of time, I created this coordinate frame in purple and set the origin of that right on the top of the water. And then here, instead of uniform, you check on this option, says non-uniform distribution. You pick your coordinate and then you go to edit equation. And in edit equation, here you provide what? Here you provide your values, and here you see it is negative rho GH. This is rho, this is G, this is H, right? And of course here my units are in meters actually. So you see that at the top it's 0. As you go down, the force gets bigger, right? So it's a linearly increasing force, hydrostatic force. And I did a similar thing for the uplift force underneath them. So let's look at this one. Again, what you need to activate is this check mark, non-uniform. Here, I picked this coordinate frame at the bottom of it. The units are in meters, and the equation is this constant rho GH, where H is H at the bottom, 30 meters, and then minus that same value divided by 20, because the length of this bottom of the dam here, this dimension here, is 20 meters. So I wanted to gradually go to 0 to the very tip of it. Okay, so once I have all that added, now I can do my simulation. But let me show you this split line option, which is very important. So if you want to apply the force to only a patch of a surface, not the whole thing, and you don't want to add some extra material to the surface, right? So for instance, I just want to apply force here. So I either have to create a very, very thin layer, a very thin extrusion on this area, so I can separate it from the rest of the surface, but that is going to change a little bit the mass of the part, the center of gravity and everything. Or if you don't want to add any material, any extrusion, just split that surface into two subsurfaces. And the way you do that, you just create a sketch. So here I went on that plane and created that sketch. And then you go under curves and pick this split line. Here you pick the curve, here you pick the surface you want to split, and then you use the option projection. And once you do that, it is going to project that sketch onto the surface and break down the surface into two parts. You see here, that's my face, that's my sketch. I use projection, and now look, here my surface is two separate parts. So I'm going to apply it only to this part here. Okay, so once everything is set, your material, your forces, everything, then you can go ahead and run the analysis. And let's see what we can get. There we go. So these are the stresses, and these are the displacements. Of course, if you don't change the scale factor, it is going to show some huge displacement, which could be misleading. So make sure you see the automatic one is 9,600 times bigger. If you do true scale, it's just going to be 1-to-1. If you want, you can use a user-defined scale, like for instance 10 times, so you see some displacement, although it's not, again, what happens in reality, but you might see a little bit of something that can happen. So this is what it is happening. Again, very hard to see at that scale. So you might go ahead and bump it up a little bit more, but keep in mind that you're just scaling it. In reality, this kind of deformation does not happen, that this guy goes down. Okay, so you got the stress, you got the strain, you can add the safety factor if you want, right? You can go and look at the safety factor and use a, let's say in this case, I use the maximum normal stress because it's a brittle material, and I create that, and you see that my minimum safety factor is about 13 and my maximum is more than 570. So my design is completely good. Of course, this is an over design, 13. But remember, these are not the only forces that can happen to a dam. There are wave forces from the water that comes. There are earthquake forces and so on. And so if you want to have a good dam, of course, the design should be way more complicated than this, but just wanted to show you some things about basically some simple elements that you need to do a relatively realistic analysis. So hopefully this video is useful to you. You learned something from it regarding material and everything, and I'm gonna see you in the next video. Thank you.